Yeah, record is started. Guys, this is Cisco packet trace. Okay. It's available in a netacad.com. So this is a Cisco Academy related only like CCNA, Cisco router switches, right? So that's Cisco Academy one. You can learn a lot of things, including networking, okay, including networking related, but not a Cisco CCNA kind of stuff. Directly can't learn. Anybody can able to log in. Okay, anybody can able to log in. You can learn a lot of free resources. For me, I'm saying it is free things. Go to the free things like view all. Okay, so go to the courses, career paths, modules, articles, languages, language based. You can see it's introduction to cyber security, ethical hacking. I think this is paid one. So self-placed mostly it is free one. So instructional means it is paid one. So it is free, free. This is not free. Check it which is free and which is you are interested IoT and digital transformations. Basic networking basics. You want to learn about networking basics or IT essentials related. You can learn. So what is this? Different type mobile network, home network, small network, media. Okay. Maybe now or later. Also no problem. It's not everything right now you should learn is not required. And this is good. Like learn about AI, learn about AI with the IBM skill builder. Okay. Anybody having like to learn again with C, C++, Python, JavaScript, okay, hardware, operating system basics. This is Cisco packet trace. Okay. So once you are okay, anything you can learn. Some are free, some are may not free. Okay. The free things anybody can able to learn. Just need to create login. No need to pay. No need to pay later. Once you have complete a course, also you will add the Cisco related batches. You learn this kind of batches, course batches. You will get it, and you can put these course batches in your resume, LinkedIn. So then your profile is get more importance for that one. If you share in LinkedIn, any recruiter sees it's you have this technical knowledge. I'm telling not only now, maybe it is later also. Already I told keep learning, keep improving technical. This is I'm talking in a network that there is lot of free resources are available. Okay, that is first one. Second one is this is Cisco Packet Tracer. Current version is 8.2.1. It's a free download, but to download it, so you need a login. So once you created login, then you can download it free. And so once you download and install the packet tracer, okay, once you install a packet tracer in your system, okay, then try to open the Cisco packet tracer once after installation. Then it is opening, but when you open, it shows this screen. Yeah, you can keep it like you keep me logged in 3 months, means next 3 months, it won't ask you this kind of logins. But to show the people, I'd never put it into for 3 months kind of stuff. Okay. So in this one, click on this green one, skills for all. Okay. Click here. Once you click here, it will take a link to your default browser and it asks for the login. I already login, that's why it is not showing. Once it is login, it shows the screen like this. Okay. So here you can get a lot of things, different types of routers. You can see these are the different types of routers. These are the different switches. The first one is devices, networking devices. These are the routers, switches. See in the bottom, switches, hubs, wireless access, wireless type of devices, wireless access point or Wi-Fi routers, even towers also there. Okay, firewalls, and these are the some DSL modem, cable modem kind of stuff. These are the end unit devices like a PCs, laptops, servers, like IP telephones, printers. Okay. In this one also like a home appliances kind of stuff because smart things we are creating right now, right? And this is IoT related practices, IoT boards. These are the connectivities. So for example, you take a PC and you want to connect another PC. So that is the connectors, different types of connectors. So some other saving kind of stuff. Okay. So first of all, I want to show you hub. Yesterday we discussed about a hub. Hub is a layer one device, physical layer. Okay, this is one sample hub how it is look like. One of the hub is given by Cisco packet tracer. So like there is a connectors. Okay, front side is not showing only the only connection part. These are different parts we can able to connect it. Leave it about it. So there is nothing to configure separation, only the display name. Because hub is we cannot configure hub. It's a fixed hub only. Okay. So this is our hub. Okay. Now I'm going to add some pieces to it. So if I press Control button and click on the PC, so I can paste this PC multiple times. Okay. Fine. So I'm connecting these pieces to my hub. This is connector. Click here. Click on this to connect one of the port. So maximum ports are limited. Okay. So maybe it's having, I think, 6 ports or 8 ports. 6 port only. Click on a PC, select Ethernet. And here also, some, whatever it is, any Ethernet port you can get. Okay. Till ports are completed. Ports are completed. It's only 6 port only, but you can add more ports to it if you want it. If required, we can add more ports. But already I told, so hub is a limited ports, limited small number of devices, right? Where is hub? Hub is used in a LAN communication. Simply I created a star topology with a simple LAN communication. Okay, simple LAN I created here. Star topology. Of course, hub is used in a star topology. Switch is also used in a star topology. Okay. We are all using star topologies. So it is used for LAN communication. Smaller the networks because hubs are the ports are very limited. So some are comes with 8 port, some are comes with 16 port. Even there is 24 port hubs also there, but hub is actually broadcast packets to every device in the network. Because of this broadcasting, other devices also getting the packets. It means A want to send a packet to B. Destination is B, but packet is also sent to the C and D and E also. So what happened here? Everyone is getting the same packet, even it's not their packet. Okay. So more traffic is created like that. While devices are communicating each other, so every device is getting the packets which is not belongs to them also. So what happened at port level of each device and entire this hub is become a broadcast domain, and again it is single collision domain means entire collisions will occur. Packet to packet collision is occur. Because of this collisions, packet data loss also occurs. Okay? And it is a layer one device, physical layer. We'll see how it is works. So So to communicate, so these pieces are required IP address. Okay, just I'm assigning some simple IP address. I'm copying it and I will see. This is I put 11. Okay, Anyway, we are going to learn about IP addresses. That time we'll see what is this IP address. But to communicate in the network, the device must have an IP address. So I'm assigning an IP address. This is 11, 12, 13, 14, and this is 15. This is simulation. That's why the interfaces are look like that one. Okay. But it works as a real one only. Okay. So it's 14, yes, 15 and 16. Okay. 11, 12, 13, 14, 15, 16. These are the things. Now, can I communicate from this first PC? This is the 11. Okay. So in the command prompt, I'm checking IP config. So there is a 11 PC. So I want to communicate from 11 to 16 PC. Yes, I'm getting reply from destination IP address means communication is there. Communication is there. The point is not that one. This is a simulation wise. Like you can put a packet here and you can put a packet here. You can see successful means from here to here communication is there. So one way of checking is try to ping to other devices from command prompt. In simulation also you can use the packet, click one place and put it on another device, check it. Do you have a communication on that? Successful means from here to here communication is available. Okay. Guys, understanding?
Yes, sir.
Yes,
Very
sir.
good.
Yes,
Very
sir.
good. Now I will show you a simulation, actual simulation. Here it is, how these packets are traveling from one location to another location. So what happened? From here to here, how this packet is traveling. Okay, we'll see. I started from here and this is the destination. Click on this packet. See the source is 1.11, destination is 1.16. Okay, and this is the source MAC address. This is destination PC MAC address. Okay, source IP, destination IP, source MAC address, destination MAC address. So port is connected to the FA0, this fast Ethernet 0 port, it is connected one. Now I go to the next step. So packet is sent to the hub. Packet is sent to the hub. So let's click it. Its incoming packet is at port number 0. But outgoing is to go to 1, 2, 3, 4, 5. To all connected devices, packet will be sent. The packet sent to the all the devices. Okay. So everybody is getting the same packet. So this devices accept the packet. This devices actually accept the packet. Remaining devices are drop the packet. Okay. So you see now outliers, they're dropping the packet. These devices accept the packet. Means it's the actual destination. Once it is taken, it is like a ping. Ping means it is ICMP. It is going to reply again. So again, it will send back to the hub and hub is sent to this device. Okay. So finally, this is a destination. Okay. But it is also broadcast to everyone. So it's successful transmission. Again, we'll try from here to here. Okay. First is packet sent to the hub and hub will broadcast to everyone. And remaining devices drop the packet. Actual destination accept the packet. In ICMP, it is always reply is there, definitely, right? So it is replying. Then again, it broadcasts. Not only one time, same to same device, take same device to same device. again it will broadcast. Okay, it's not a one time, every time it will broadcast. Not a one time, it is every time it will broadcast. So it is hub is a broadcast domain. It is not only, yeah, everything, both are broadcast domain only. Okay. My point is hub broadcast packets to all connected devices. That is the main difference of hub and switch. We'll see the switch also, don't worry. Let's understand hub,
Yes, sir.
Yes, sir.
switch. Good. Good. Now we'll take switch from PCs. Okay. This is the switch, guys. This is Cisco 2960 switch, 2960 switch. It is layer to switch only. Okay. And it is manageable switch, means we can configure inside. Okay. So 2960 switch series it is. It contains, right now it is contain 24 ports. Okay, 24 ports are there in this switch. Same like a hub, we are connecting the devices from here to here. Okay. So once again, control this straight cable. So I'm connecting. So in any port you can connect it, not required to be connected in exactly 1, 2, 3, 4 like that. Yes, it's simple simulation pattern. Yeah. So I connected 6 devices also here. 6 devices are available. So these are the 6 devices. So we can connect up to 24 plus 2 devices. You can connect it because it contains 24 fast Ethernet ports, 2 gigabit Ethernet ports are there in this switch, particular switch. Again, so what we have to do? We have to assign IP address. 190.168.1. This time I will take 21. So there it is. I started with 11. This time I will take in 21. Okay. Both are so that is 21. This is 22. So this is 23. 24. 25. And 26. Okay. So this is my network on LAN communication. From here to here, we can communicate. So this is a command prompt. So I'm checking first what is my IP address, IP config. So my IP address is 192.168.1.21. Now I want to check whether I can able to communicate to 22 or not, for example. So what I'm getting? Yes, reply from destination IP address. Meaning is from this PC, from this 21 PC, I can able to communicate it to 22 PC. Both side communication is there. This is one of the test, like ping test. Okay, whether you are able to communicate from here to here or not. Same way. So you can use this packet dropping from here to here. From here to here, can you communicate? Yes, successful. Okay. So what is happening here? Okay. So what is happened when these devices are communicating each other? This switch take the incoming packet. So whenever packet is sent, first packet will send to this switch. And what switch will do it? It take that packet, check this device MAC address. How to check the MAC address? IP config IP and MAC, both I want. IP config space / all. Okay. So this is the MAC address of this PC, PC3 MAC address. Port number is, sorry, IP is 21 and this is the MAC address 009021C25530. This is the MAC address of this PC. So, and this is the destination. Okay, this is the destination. Same IP config /r. So, okay, this is the MAC address of this PC8 22 system. Okay, so what I have done, I communicated to this PC as well as this PC. Right? Whenever the packet came to the switch, first packet sent to the switch. And what switch will do it? Switch take this packet, check its MAC address, okay, in an incoming packet, source MAC address, check your MAC address, and which port it is, port number is F0/1, F0/1, fast Ethernet 0/1. It mapped this port number to this PC MAC address. Like that it happens. We'll see this is I can able to interact with my switch because in simulation directed. In physical switches also you can do it. Mainly manageable switches you can do it. Show MAC address table. Okay. So it is, so this is the PC1 MAC address. See the MAC address here. See the switch here. See? The PC1, that's the first one. That's a 21 PC is connected. This PC is connected to port number 1. Okay, and its MAC address. See, this both are same MAC address. Okay, same. It is 2, 3, 4, 5, 6, like this. So what happened? Whenever packet is came to the switch, switch take its PC's MAC address. Switch take its PC's MAC address and put it in the its MAC address table. Means MAC address and which port it is connected, which device, their MAC address, device MAC address, and which port the device is connected. It map like that only. Now, I want to communicate it to this second PC. So second PC destination MAC address. It checks destination MAC address. This PC's MAC address. It check in this MAC address table. See where is the MAC address in that one is this one, right? This is 10010, all ones. Not here. This is the one. 0010, 4 ones, E8, right? Like this. This is the, see. Okay. This is the destination MAC address. It check where is the destination MAC address, which port it is connected. Then packet forward to this port only. So it won't do broadcast. If not, find. For example, this PC is communicating to this PC, but MAC address is not found in this. In this table, destination MAC address is not found. What it will do? It broadcasts the packet. It broadcasts the packet. We'll see in simulation how it is happen. From here to here, this source, this is the destination. Source IP 1.21, destination is 1.22. Source MAC address, destination MAC address. When packet came to the switch, it checked the source MAC address and the port, put them into MAC address table. Okay. So first part is that one, right? It's taken and it checked the destination MAC address. Okay. First is MAC address table complete. It checked the destination MAC address. Okay. It checked the destination and it will try to find destination MAC address in the ports. In the MAC address table, it it will try to find where is this MAC address in the MAC address table and try to find the port connection. It is there, then directly it will send other unicast. Otherwise, it will broadcast. Now I think it is doing broadcast. No, it's send and receiving also. Go back. This like unicast. We'll do again because second time definitely it is show properly. So packet sent to the switch. Switch check its destination MAC address. And where is the destination MAC address is located? Port number 2. Actually, in earlier that is a broadcast. Now it is just unicast only. Not sending to everyone. Not sending to same time from this PC to this PC. Okay. First it will send to the switch. The switch take the source MAC address and the port number, put it in the MAC address table. Next, it check the destination MAC address. It check in the MAC address table and which port number it is mapped. If it is fine, unicast. Not fine, broadcast. If not fine, it broadcasted. And destination is received finally. Remaining drop the packet. First time. So anyway, it is replying, right? This time it is replying means packet is reply. It came to the switch. It comes with the destination MAC address like this. That is connected to the port number 1. It's sent directly unicast. Okay, based on incoming packet only, it will create. Again, same to same communication from here to here. Again, same. Earlier broadcast. Now what it will do? Again, it will check the destination MAC address and destination port number. Right? So it will broadcast. No broadcasting. It is unicast. So initially it is broadcast, but later it is unicast. Why? How it is unicast? So always it will check in the MAC address table. It find, then it will forward. Otherwise, no. Okay. Otherwise, broadcast. Okay. Once again, I will type it because that's the initial MAC address. Now it is, this is exact communication. Port number 1, port number 2, port number 3, the connected devices MAC address. If you see these port numbers, 4, 5, 6, 4, 5, 6, okay, these 4, 5, 6, okay, are not showing in the MAC address table. Not showing in the MAC address table. See, right now it is not showing. This is just initial one, but now it is not showing the 456. For example, I am communicating from this PC to this PC. First time. Okay, source MAC address 21. This is 24. So I don't know where it is located. It is in my network only, but which port we don't know. Which MAC address also we don't know. Packet sent to the switch. So it is saying it is MAC broadcast. It will broadcast to everyone. So initially it is broadcast. It check its port number like this. Okay. Now it is replying again. So again the destination MAC address is at port number 1. And replying and send back. First time it is broadcasting, right? But second time try again. It unicast. Okay, it's not broadcasting again. So that's the main difference between hub and switch, guys. Hub is a layer 1 device, switch is layer 2 device. Hub used for LAN communication, switch is also used for LAN communication. Hub used for small networks, switch used for small and large networks also. Hub broadcast packets to all connected devices. Switch use MAC address table to unicast the packets. Okay. Switch uses MAC address table to unicast the packets. Okay, switch learn the MAC address of connected devices when they are communicating. It create a MAC address table. Okay, switch initially broadcast, but later it is unicast. How it can be unicast? Using MAC address table. So this is the difference between hub and switch. Guys, understand somewhat? Hmm? Anyone? Or you got confused? No one is speaking anything? Understand the differences?
Yes, sir.
Yeah, you have to be active, guys. Because yesterday, little hurry, I told this concept, right? So these are the different networks. This is separate network. This is another network. Maybe they are located in same physical location or maybe different locations. For example, this is in New York and this is in New Jersey. Okay. So, or maybe this is in India, Hyderabad. This is in a some New Jersey, for example. Okay. In this network, so I have a different devices, right? Some PCs are there, and as well as some servers also there. Okay, some servers also there. In this network. So I'm connecting this network from this server to the port. Now, this is one network, one logical network, of course, like this. From PCs, I'm going to configure some network. Give here it is, it's 172.16. Any a number I can put it at my wish to put it. Okay. I'm also configuring default gateway here. This default gateway is nothing but IP address of this interface. Okay, this interface IP address is my default gateway because I want to communicate from here to here. I don't need a gateway, but from communication from here to outside, it has to send to the default gateway. Okay, that's why I have to specify the gateway address. That is 11. This is 12. This is the gateway again, same gateway. This is 13. This is again same gateway. And I have a server. We can make any kind of server it is like DHCP server. You can make it as a DNS server or HTTP web server also, just for a simulation purpose. See, this is my HTTP server is on, and you can edit any of this kind of stuff also, index.html like that also. You can edit. I will going to edit this hello world only. In hello world, I am putting a welcome to the world. I put some changes. I'm doing it. Some header I'm putting. Welcome to um, networking class. Okay, just save it, save it. Okay, if this server also need an IP address, so in the same network, I'm putting an IP address is 14. And as well as default gateway, also I'm specifying here. Statically, I'm configuring all IP address. Okay, so this is server, and this is my client PC, right? And I'm trying to check, can I communicate it to this server? So 172.16, 1 dot, so 0 dot 14. Yes, ping communication I am doing. So I'm getting connectivity. Connectivity is there, but that is a web server. You have to access the web server with a web browser only. Website we have to access with a web browser. HTTP colon slash slash 172.16.0.14. It is Cisco packet tracer. Website is open. A small page. See, welcome to networking class. That's what I added there. Okay. So I can able to access the server from here to here. Okay. Also I can access from here to there also from another system. Okay. So what is this, guys? Intranet. Intranet. Okay. I can able to access this server. So communication is there and connection is there. This is one network, one LAN network it is. Intranet, my private network it is. So from here to here, I can able to access it. Okay. Here also I have a PCs. Okay. And I'm connecting from here to here. This is another LAN. This is entirely another LAN network. So they're also having some IP address. So I'm putting 172.17.0.11. This is 17, that is 16. Okay. Or we can use different, completely different type of network also, we can do it. Okay. Now I can able to communicate from here to here. Okay. Ping 172.17.0.12. Yes. From this PC to this PC, I can able to communicate. Even if I have a server here, I can able to access that server. For example, you want to put a one server here also, you can put it that server. Okay, server means you should assign IP address on. That is 1, 2, 3, 4. Assign IP address as well as service. Same hello world here. I'm going to add some header. Welcome to, that is I put a networking class. This is I will put a what we can say router class. Okay. router class. Some just for differences. Great. Okay. So can I communicate to 14? 14 device communication is there from this PC to 14 ping communication is there. Go with the web browser, http colon slash slash 172.617.0.14. Yes, pages is accessible. Good. Good to see that one. Okay. But this is one LAN. This is different LAN. Different private network it is. Different private network it is. If this is one intranet, this is another intranet. Okay. From this PC, I want to access this website. So right click on here, http colon slash slash 172.16.0.14 it is. Okay. Not getting anything right now. Why I'm not getting? Why can't able to access this website from here? From here, why can't access this site? Anyone? I can access from here to here, but I can't access from here to here. Why? Anyone, please? Guys, is anybody listening? No response, yes, no, something, I don't know, at least.
I don't know, sir.
Okay, good, that is also good. Anyone?
Don't know.
Any guesses also? Any guesses? Guess it. That's what increases your thought process, guys. So I'm keep on giving these lectures from not only your batch, for every batch. But thing is, it's important for you to think different guesses. There is no right or wrong answer. If you given wrong answer also, for me, no problem. See the diagram. I can able to access this website from here to here, here to here. Then why can't able to access from here to here? I can't able to access this one. But this is I can able to access. But why can't able to access from here to here? Right now, at least now.
Not connected, right?
Yeah, they are not connected. That is, this is different network and this is different network. And we didn't connect it at all. Okay, we didn't connect it. So how can they communicate if you don't connect it? Very good. Very good. Okay. That is what guys learning means. We came from different academic backgrounds, different academies, colleges, some lectures, now YouTube videos. One way of teaching, another way of just listening or forgetting only. What we are not doing is thought process. Think. Okay. If you think, then only we can able to learn. Okay. Good, good. We are not connected. Very good. That's a correct answer. So this is one LAN and this is another LAN, which is, I will put in a different color. This one. Now they are not connected, but how they will connect it? They should connect it through WAN only. Different geographical locations generally will connect through WAN communication. So this is a router. The router is actually symbolic representation is round, but original router is look like this. A square rectangle boxes only. This is the back side of the router. This is the front side of router. Okay. So this is in the router. Okay. In the router, we have auxiliary port, console port. This is LAN ports. This is a LAN ports, and there is no WAN port right now. So I am going to add a WAN port. See, this is a HWIC2T. This is the WAN port. See, serial high-speed WAN interface card. So to connect through WAN means we need a WAN interface. This is the WAN interface. So turn off the router. This is a module router. So I have to put it like this. Drag and drop here and turn on the router. Now we got this interface. This is the WAN interface. This is LAN interface.
So here we connect according to the place. Like if it is a lodge, then we'll use the van. If it is small, like local, then we use the land. Is it this kind of thing?
It is almost like that only. So for example, um, both are in the same location, same physical location, same building kind of stuff, or next building, like a CAN kind of stuff. So we don't require WAN interfaces here. Okay, just LAN interface wise also we can connect it from like this is one LAN, this is another LAN, and we can connect them together because this is different network. This is another different network. You want to make a communication, you can directly connect it. You can directly connect it to one router or different router, one router you can connect. But
So
different
can you give
location
a
means, yeah,
sorry,
tell me. Yeah, tell me, tell me.
a real example so that I can understand better.
Originally, how it is connected. Originally, as I said, this is New York location. Even it is Hyderabad, Chennai, Hyderabad, Pune, Hyderabad also. Different offices. So they want to connect through WAN type of connectivity, means how actually they are connected. So this is connected to a service provider. Internet, these WAN service providers are there, separate, like a BSNL, VSNL, HCL, Icona, okay, Tata. So there are different service providers are there. So we'll connect it to that service providers. That's it. For example, forget about this. This is Hyderabad. In Hyderabad office, we are connecting to this service providers. And this location, this side location, for example, it is Chennai. Chennai. Chennai nearest their service providers. Maybe it can be HCL or Tata or Ticona, like that, or BSNL. Their service provider, they will connect it. These service providers using different fiber optical cables, they will connect each other. Okay, they won't connect. No one is connecting directly to directly. So they're also connected through different routers wise. So in between there is a lot of connectivities. They're also connected in different ways. So there is a connectivity. Okay. So virtually say they are connected directly. Physically, they are connected through different fiber optical lines and not only that, in this world, there is a lot of service providers. All are connected through these fiber optical cables. We are all connecting through service providers. Okay. So for example, this is my Hyderabad data center. I have not only web server, I have a database server, storage server are there. In another office, in Chennai office, they want to access my database server. they can't access directly, right? So whatever, so we are connecting through like this. So they are connecting, we are connecting like this. This is called a dedicated connection. Leased lines are dedicated connections. So from our network, so we are connecting to the service providers. Service providers are make a connectivity, and we do some agreement between them. So this is my network, and this is another one. So make a virtual connectivity, a dedicated connectivity between them. So these service providers will do that connectivity between our networks. Okay. So this is how we are connecting using different WAN technologies, different WAN protocols we use it. Like PPP is one of the WAN technology. HDLC, another WAN technology it is. Okay, between WAN these devices. MPLS. Nowadays, mostly we are using this MPLS only. Next is SD-WANs. Okay, now we are getting this smart cities kind of stuff now. So this is SD-WANs. Using different WAN technologies, they will connect from our network to our other network between them.
So they can't connect it directly without these service providers.
We can't connect directly from here to here, we can't connect it. Because if you are connecting, so many are there, means how many wires required? Lot of wires requirement, right? So we are all, not only me, some other organization also connected to the same service provider. Some other service. So these service providers have a connectivity, a common connectivities are there. So they
So
will
using
channelize this
this
connectivity. You tell
service
me?
providers, we also have a lot of malfunctions and hackings.
No, dedicated connection means complete, means where my packet is traveling, there your packet won't travel. Okay, my organization, that that is called a dedication. Dedicated connectivity means whatever I sending a packet, it's not about a cable, it's like a channel type. So in that channel, your other packets won't travel inside. It will take time to understand. So generally, we are
Service,
connected to, okay, service providers. These service through service providers. So whatever they it, what is your ID? There is an identification, your connectivity and your other branch office connectivity. Okay. So between them, these service providers establish a connectivity between them. Okay. It's like a one, it's a private, this is also private, both are connected each other. Okay. So to connect like that, the technology what it is like a PPP. So between them, authentication is there, like a PAP authentication, CHAP authentication, MS CHAP authentication, different authentication. Both are authenticated, then only connectivity is established. Different techniques also there in between for securing one. Okay. It's called dedicated lines. Okay. So in our simulation, so we do not use any of these service providers and all. Direct WAN connectivity is there. So we use that one. Okay. It depends, guys. Again, it's not required to be geographically wise separated. It's not required geographically wise separated. Okay. It's not required to be geographical. So it may be one room to another room also. You can create WAN connectivity. Okay, so different things are there. And how it is possible means there is a DTE, DCE type of back-to-back connections. So between these two networks, if you use WAN type of connectivity between, means through WAN interfaces, WAN protocols you have to use to connect. But in generally, when you are using even it is same location or different location, means mainly different locations. We do not establish a single wire from our network to the destination network, no private lines are there, no physical private lines are not there. Okay, no direct lines we can't put it. Why? Because of, so you have to pay for digging the road, right? So that's practically difficult. Already 20-25 years back only, people are put this fiber optical cables, underground fiber optical cables are there. One of the thing is BSNL. First one is BSNL, VSNL, Vijay Sanchar Nigam Limited. BSNL combination. So there is already underground fiber optical cables are there. Second one is Reliance. Reliance means not this Geo right now, not Geo. Right now, it's Geo is actually, so original mother is Reliance, right? So that time only, in that time government also it is given for a Geo, underground fiber optical cables. So that time I am also studying in Hyderabad, right? So I have seen this. People are digging, so checking wires underground. Okay, Tata. So many years back only, Tata also put a underground fiber optical cables. Some other service providers take their fiber optical lines, they use these connectivities and create their own internet service providing. Okay, so only few companies are having this dedicated lines. Okay, underground lines. So we are using that lines. Okay, into that one only. So we can't put our own wire from Hyderabad to Chennai. We can't put it. Okay. Right. Very good. Very good. That's actually very important point of WAN connectivity. Okay. Right. Yeah. Where are we? Yeah. This is our router. This is a WAN interface. This is a LAN interface. So you can see this side is a LAN interface. This side will go with the WAN interface. Okay. And this router also need a WAN interface. So look at here. I'm inserting a WAN interface. Okay. So this side is LAN interface. This side is WAN interface. Already I told guys, we are not using any mid service providers here in the simulation, just directly back-to-back cable like this. So WAN connectivity, the thunder symbol represents WAN connectivity. You can use this type of cable, serial DC, DTE type, okay, or you can use this thunder symbol. So automatic selection of this DCE, DTE connections, okay. This is Hyderabad office, this is Chennai office. And both are connected through network. It's like this. This is another network. WAN network it is. Okay. This is WAN and this is our LAN. Okay. Now these are get connected, but actually we didn't configure these connections. Don't worry guys, just I'm configuring it. Okay, we can configure like this also using interface configuration. This is gigabit 0 by 0 interface. So this PC is gateway. See the gateway IP address? Okay, the gateway is nothing but this interface only. So I'm configuring these interfaces. Okay, I'm configuring this gigabit 0 by 0 interface here. Okay, simple way I'm interface is just click on and I'm giving this gateway IP address here. That's it. Now it is done now. This side also. You see this gateway. See the gateway. This is the gateway IP address. So this interface, again, config interface, IP address, subnet mask, and turn on. Okay, it's on. So this side configuration is done. Okay, and next step, these interfaces, they have to connect, right? So I am going to that is serial 0 by 0 by 0, this line. So I want to give an IP address to it. So some random 100.10.22.1 and on. So copy, because it's a direct connectivity, same, but little different, small difference. Okay, it is also on. Now connectivity is there, but still we can't able to communicate. Still we can't able to communicate. One 16.0.14. Still we can't communicate. Okay. Even you try for the simulation from here to here, in progress, no communication. So thing is, you want to communicate from here to here. Packet sent to the switch sent to the destination. Okay, and again you're replying to the destination. From here to here, we can able to communicate. But when you want to communicate from here to here, now connectivity is there, but packet sent, it's a directly it will send to the router C. Directly it is sending to the router, not sending into the broadcasting. Why? Because of it's a different network. We are communicating to different network. The packet obviously go to this default gateway only. The packet is obviously go to the default gateway only. Okay. So when you are communicating outside of your network, the packet is automatically sent to the default gateway only. You want to communicate from here to here, packet must send to this gateway only. But why we are not communicating? Because these routers don't know how to reach this destination. So for example, here again, just this the last. This device want to communicate to this device, right? So this is different network. So packet has to send to the gateway, this gateway. This is the gateway address. And it is entered into the router. The router must know where is this network? Where is this network location? Okay. So you must know the location. Where it will check? In the routing tables. In the routing tables. In the router routing tables, it will check. So in this routing table, it has to be mentioned to reach this 170.17.0.0 network is located in this site. Okay, it should be in the routing table. If not there, we don't know how to reach it. If it is there, then only it will send it. Same for this routing table. In this router, when this device want to reach this destination, this site, it will check the packets, destination address, destination network, and which way the packet has to be sent. It check in the routing tables. If not there, it cannot send it. We'll see this router's routing table. So IP route. Okay. If you see there is information about 170.16 and 100. Those information is there. There is no information about 170.17. Okay, in this router, in the second router. So IP route. In this one also you can see it's knowing about 100 network and 170.17 network. It's not don't know about a 16 network. Okay. So this router don't know about 16. This router don't know about a 17. So what I have to do? Either I have to configure, I have to tell to my router. So I have to tell to my router. Okay. There is a network. There is a 17 network. Is to reach 17 network, you have to go like this. To reach 16 network, you have to go like this. I have to tell to my router. Such is change the name. I have to tell the router. Either manually I can tell or I can get it automatically. Automatic means using some routing protocols. But manually I am telling IP route to reach 170.17 network. Okay. So you have to go to this interface. Okay. So I told that one in my routing. So you want to reach this network, the packet has to send to this interface, 0 by 0 by interface. Same in the second router also, I'm telling. You need to understand the configuration, just understand the routing part. Route, you want to reach 170.16.0.0 network. You have to go to this interface. Means you are telling go left or right kind of stuff. Okay. You are telling go to right or go to left like this. Okay. So simple I find. Same show IP route. See now this router knows to reach this network, packet has to be sent to this interface only. Has to send to this interface only. In this router knows now to reach the 16th network. Okay, packet has to send this one. So I configure these routings statically, means manually enter, that is called static routing. Statically I configured it. Okay, now we will check it. Can we able to access or not? Again, same thing. So what I'm trying from this PC, I'm trying to access this one. http://172.16.0.14. You got it? Small page. You got it now. So we can able to communicate from one network to another network via these routers. Okay. So what is the router will do? It make a communication between different networks. What router is doing? Router is an inter-networking device. Router is inter-networking device means it make a communication between different networks. It make a communication between different networks. Inter-networking device. It's layer 3 device. Network layer device it is. Next. Networking. Okay. And it use routing tables to tell how to reach the destination. So router will tell how to reach the destination, right? Router shows best path to reach the destination. It uses these routing tables to show the path to reach the destination. So using routing tables, it shows the path to this destination. It using both LAN and WAN connectivity. It will connect both LAN and it will using both LAN and WAN communication. Okay, LAN and WAN communication we are using. Okay, and coming to the switch and router differences. Switch is layer to device. Router is layer to device. Switch works with the MAC address. Router works with the logical address, means IP address. Switch used for only LAN communication. Router using both LAN and WAN communication. Router using both LAN and WAN communication. Again, layer to layer travel communication. Switch use MAC address table to unicast the packets in the LAN. Router use routing tables to forward the packets to different networks. Router use routing tables to forward the packets to different networks. Router act like a default gateway to forward the packets from your network to other network. Okay, for your network, it is act like a default gateway to forward the packets. Okay, so these routing tables can be configured manually called static routing, or these routing tables automatically be created using dynamic routing protocols. That's it. Guys, understand the differences, at least some clarity you got it about routers, switches, hubs.
Yes, sir.
Okay. So I can tell just the differences, but I want to show really how the differences are there. Only that is my try, okay, to show you that. And what we discuss here, this is not router. This is we discuss about hub and also switch. Discuss, okay, and also we are going to discuss about a so wireless access point. So this is a one LAN. Okay, this is one LAN. This is also a LAN. Okay, I will last one is I will show you that WLAN last one like a wireless access point. This is the wireless devices. This is wireless home router, but I need a just wireless access point on. This is WC. This is WRT. This is also router only. AP wireless access point, access point, access point, access point. I will take one access point and see how it is look like. So simple access point it is. Okay. See the simple packet tracer access point. Okay. This is for incoming connection point. Here it is. And there is a two antennas. Configure port 1, port 0 on port 1. Port 1 is for SSD configuration. Okay, just wireless access point. That's it. Nothing more here. Okay, just like a switch tab. Okay, in that routing, then I will put a wireless router also. This is simple access point, guys. Purpose of why purpose? What is the purpose of wireless access point is to connect wireless devices. It can be your PC or it can be your laptop. Okay. You want to connect these devices wirelessly, you can connect. Okay. So for that one, these devices must have a wireless connector. So they must have a wireless connectivity. So we need some, yeah, this is 2.4 gigahertz. See, wireless adapter. This is the wireless adapter. So what I'm doing is I'm removing my original one. So first power off, then remove the one. Insert wireless adapter here. So now wireless adapter is inserted into my desktop. Already seen they required NIC. N for a laptop. Okay. So power off the laptop, remove the NIC, put a wireless. This is a 2.4 gigahertz wireless. So your router also must support 2.4. Then only we can connect it. Okay. It is actually established the connectivity as earlier. See. Power off. Remove the LAN and put this one. Now on. Okay. Now can you see? This is wireless access point. Now I created WLAN. Now I created a WLAN. But thing is, by default configuration, it is selected. See, port number 1, it is showing a default. Now I want to show you that's like turn off the wireless. It's gone. I'm changing the name to default to some name. Okay, some H12. My wireless name is H12 wire plus. Okay, and it's a 2.4 gigahertz channel. This is a authentication is disabled. This authentication is very important to know, right? So I am selecting some authentication. Simple password. So it is, I use only PSK, okay, WPA, wireless protection authentication type, WPA. I'm using this authentication and it need a password. So my password is simple admin is my password, okay, and encryption type is AES. AES is the authentication type. And turn on. Okay, it need 8. Okay, 1, 2, 3. Admin 1, 2, 3. Yes. Now I configured my Wi-Fi wireless access point. I given a name. Name means SSID, connection name. And I given a password. So authentication method is PSK I given, password is given. Okay, that authentication type can be AES or TKIP. Okay, I use authentication type like this. Okay. Now these PCs, now it is not connecting. See, why it's not connecting? Default configuration is changed. So I have to connect it, right? So go to the connections, refresh. Generally, you will click here, right? So you will click to list the connection names. Same thing I'm doing here. So go to the connection, just refresh, link information, refresh. This is the default profile. But it's not getting. Both are 2.4 only. We'll try from here. From laptop it is. Connection, refresh. Just I'm trying to get the list like this only. Something mistake I have done here. Yes, mistake is you have to put in real time. Options selection problem. it lists out all wireless connections available here. Why it is not showing that? I'm necessarily attached it. Somewhat. Something I got it. Yeah. H12 wireless channel 1 signal is 59%. Click here. See, we got our SSID means connection name. We got it. Okay. And click on connect. Okay. So we'll put a password. Admin 123 password. Connect. We got connected. We'll see we connected or not. So we got a connectivity. Same for other devices. Refresh. Yeah, we got it. It's taken a little bit time. Okay. Yes. This is also connected, and even just what we need is an interface. Wireless access point. So what I created a simple wireless LAN. I created a simple wireless LAN. Again, to communicate in between this network, so what we need is an IP address is required. Okay, what we need is IP address is required. 172.16. There I given 11, 12. This is sorry 11, 21. This is 31. Just for fun, I'm giving that. Really, there is no specific reason. Of course, I have my own specific reason, but for it is no specific reasons. For that one, again, you have to understand the IP address, network address. What I want to show, simple WLAN. So what is this? A WLAN, a wireless LAN. This is my wireless LAN. This is LAN with a switch. Okay, this is the LAN I created, the switch. And this side, I have created a LAN. This side also I created a LAN only. But this time I use hub. You guys understand? LAN, WLAN, wireless, access point, and WAN. This is a LAN, and that is WLAN.
Yes, sir. I forget what color I used there. So I will create like this is entirely LAN. This is entire our office. Okay. This is our office, our LAN. This is another LAN. And this is WAN. Okay. So both are running in different networks. So they are connected to WAN through router and we are able to communicate each other. So one more is there that is called our Wi-Fi router. So we'll see that Wi-Fi router configuration also today after a small break. Okay, take 10 minutes of break. I've taken for a really long time and even when these kind of simulations won't tell me the time. Okay, we'll keep on going. Okay, take a break, guys. 12, already 12:24. Okay, take 12:35. Okay, take 10 minutes break. We'll see Wi-Fi access, Wi-Fi router, that Wi-Fi communication also. Configuration and SOHO, everything we'll discuss.